Hello all, this is K. Mohit from Civil Engineering Department 241 CV 132, and today I am going to present about the topic Hermite Interpolation. So, first of all, let's see what is Hermite Interpolation. Hermite interpolation is a method of polynomial interpolation where you not only know the values of the function but also know the values of its derivatives. So it says that we should be given the values of the function and also the values of the derivatives of the function values. Unlike the regular Newton's or interpolation or Lagrange interpolation, like they only use the function values, but here in Hermite interpolation we use function values and also its derivative values. And after we get the interpolating polynomial, we see that the all the values will be matching by the given values for the function. So hence we will get the curve with the same derivative also. Like in Newton or Lagrange interpolation, it only matches f of x, but in Hermite interpolation we will get the same slope also. Like after we derivate the Hermite polynomial, we'll get the same slope according to given values. So let's see the concept behind it. So initially we are given the data points, and they are x naught and f of x naught, x1, f of x1, and so on, f x n and f of xn. And also we are given their derivative values. They are f dash of x naught for corresponding to x naught and f of x naught, f dash of x1 for corresponding to x1 and f of x1, and so on, f dash of xn corresponding to xn and f of xn. And we use all these value to create a single Hermite polynomial h of x, such that h of xi is equals to f of xi for every f of xi given, and also h dash of xi will be matches to f dash of xi given. So in this way we are going to calculate Hermite interpolating polynomial. Hermite interpolating polynomial has a general formula, as we can see, h of x, and h of x will be equals to summation of I from 0 to n h of I f of xi and h cap of I f dash of xi. And like we will calculate initially the values of hi and h cap of I for every given data point, and we will calculate the resulting Hermite interpolating polynomial. And we can see that hi of x is equals to 1 minus 2 x minus xi of l dash of I xi and li x whole square. And this lix is known as Lagrange basis polynomial, and we will talk about Lagrange polynomial now. And h cap of I is equals to x minus xi and Lagrange polynomial whole square. And Lagrange polynomial we will get as product of x minus xj by x minus xj for I not equals to j until n. From this we will get the Lagrange basis polynomial. Okay, let's see the step by step procedure how we can get the Hermite interpolating polynomial. We are given xi, f of xi and f dash of xi. From that, in first step is to calculate the Lagrange basis polynomial li of x, which is this formula as I said earlier. And then we have to differentiate the Lagrange basis for polynomial, so that we should get L dash of x, which is the derivative of the given Lagrange basis polynomial. After that, getting those two values, we substitute these two values to get hi of x and h cap y of x. And at last we will do the whole summation, and we will get to know about the interpolating polynomial. So let us consider an example. Let's find an h of x that interpolates x, f of x and f dash of x are given for values 1, 2, 2, 3 and 3, 1. So for computing li of x, by substituting in the previous formula, we get L0 of x for the value of 1, x equals to 1. We get the L0 of x as 2 minus x, and L1 of x, which is the value for 2, x equals to 2, that is x minus 1. And for second step is, as we know, derivate the Lagrange basis polynomial. So we get L dash of x equals to minus 1 by, as you can see, derivative of constant is 0 and derivation of x is 1 and minus. So minus 1, and L dash of 1 of x is, we can see here, derivation of x is 1 and derivation of constant is 0. After getting those two values, we will go to the next step. In the next step, we will see we have to calculate hx and h cap of x. And hx, we have the formula, and if we substitute the Lagrange basis polynomial values in this, we will get h0 and h1 of 0, and their values are x minus 1 into x 2 minus x whole square, and similarly we will get h cap of 1 also. And at the last step, we will do the summation, and after summation of that value by substituting all this, we are getting a polynomial h of x. By simplification, we can see the h of x is 2x cube minus 10x square plus 17x minus 9. And this this method is like can give the very smooth curve for the given values, but this is very lengthy method. For like if we have like 2 3 values of x, we can do it easily. Otherwise, we have another method for this, and that is by using Newton divided difference, which we will see next. In the divided difference method, what we will do is we will write every value twice. X, we got 1 2, so we write 1 1 2 2. In the same way for f of x, 2 2 2 3 3. And first differentiation also we should take in the Hermite interpolation, so 3 1 1 1. And after taking all this, no, and after taking all this, then we should make a Newton's divided difference method table. And from the table, we get f of x naught comma x naught as 3, f of x naught x1 as minus 2. This is the second differentiation value. And f of x naught x1 value as 2. This is the third differentiation value. And from this, we will we will use this divided difference table to calculate the Hermite interpolation polynomial. Yeah, as we know, by the divided difference method, the polynomial we get is f of x naught plus x minus x naught, f of x naught comma x naught, and so on. By substitution of the values and simplifying, so we get h of x as equals to 2 plus 3 of x minus 1 minus 2 of x minus 1 whole square plus 2 of x minus 1 whole square into x minus 2. By simplifying, we will get as h of x is equals to 2x cube minus 10x square plus 17x minus 9. And also, if you want, we can check h of x is equals to 1 and x is equals to 2. We will get f of x as 3 and h dash of x as 1. So in this way, we can check and verify the Hermite interpolation polynomial. So this is the code which has been written in the Python for the Hermite interpolation. First, we have to import sympy, which is the used for mass in the code, and we have to define x as the variable symbol here. And then we have to input the given data points, so that we will get the output. For that, x points are 1 comma 2, f values are 2 comma 3, and derivative values are 3 comma 1 as given in the previous question. And then we have to define L of I, and this L of I is basically a Lagrange basis polynomial. And as you know, this for loop is for like repeated product used in Lagrange interpolation polynomial, and we have to input our I. and next, let us assume our Hermite interpolation polynomial as 0 in the starting. And then in this for loop, we actually run for the Hermite interpolation polynomial. As first, L of I is basically taking the value from the Lagrange basis function, and L of p is the differentiation, and sp dot diff is basically doing the differentiation of L of I. And h of I is basically, like, we know the formula of the hi and h cap of I, and we are simply like doing both by using the formula directly. And at last, h is like, we know h is the like plus it is the repeated addition of the by the for loop by the given values of hi and h cap of I. And after all this, like this is the h of expand. This expand is generally used for the to show the output, and at last we will print the Hermite polynomial. And we can see the output here. This is 2x cube minus 10x square plus 17x minus 9, which we got as the output by the normal method also. And in the here verification is also given by the code. In this way we can able to calculate Hermite interpolation polynomial. Thank you.